point out, we do not have AC in San Francisco unless it's the movie theater, pretty much. So if it's 90 here, it's just 90 degrees in my house, or hotter even, because it's an old building. I don't actually know how hot it is. I'm gonna look. How is it in East Bay, Stephanie?
Actually, it's really nice to meet in the East Bay right now, but I'm also indoors I've been indoors the whole day / week, so maybe it's just the AC.
Oh, you have AC?
Yeah, well, it's HVAC. I'm not sure if it's actually AC. It's like some sort of blown air.
Ooh. Oh yeah, it's like 97 over here.
It's not typical for San Francisco.
I'm in the Mission, so it's about 5 to 10 degrees hotter here than most places in the city. Because it's like the valley and all the heat, settles. But yeah, it's hot. It's really hot. Ugh. All right. I think tomorrow's supposed to be better. Finally. Thank you. I'm not a fan.
Too bad the water parks aren't open right now.
The what?
The water parks are not open.
They are?
They aren't. I don't think they are.
Oh. Well, hold on 1 second. I've got to get this call, so I'm going to mute myself for a minute.
No,
I actually don't even know how to do that. Wait, hold on. Because I'm screen sharing. How do I? Oh, here we go.
So while we're waiting for other folks to trickle in, I'm going to just copy and paste in a link to the slides. Let's see. Into the chat. And the link will also be in a bunch of the slides from the actual slide deck too.
All right. Hi, guys. I'm going to get started just introducing the event today. So hopefully you've joined us for the previous workshops. Welcome to BitRate Machine Learning and Music series, presented by the Magenta team at Google Research and Gray Area. And this next slide shows you the team, one of which today we have Stephanie Andrews, who is going to be leading you through ml5.js and what the magic is that you can explore with machine learning and music. So I'm super excited myself because I'm not super familiar with this library, but it's just really fascinating stuff. And this is just a slide of the workshops we've done so far. I would like to point out that all the workshop live stream broadcasts are available on YouTube. You can get access to that via DevPost, bitrate.devpost.com. You can also join the Slack channel. If anybody needs links or anything to that, I can give it to you. I posted and reposted the links again and again into the announcement Slack channel, and as well as it's in the update section of DevPost. So if you want to watch those other workshops that you missed, that's totally there for you. The next thing I want to mention is just what gray area is, because I know that some of you might not know who we are or what we're up to. In a non-COVID world, we would be doing this series in the Grand Theater in the Mission, which is where I'm located right here. And Gray Area is a nonprofit that's a cultural hub applying interdisciplinary creativity toward positive change in our community. We work with creators from diverse backgrounds to critically engage with social, cultural, and political issues through events, exhibitions, and conferences, educational programming, research labs, and artist residencies. And the other partner that we have working with us is the Magenta team at Google Research. We've been working with Simon, who's been amazing and helping us put this all together, as well as just a shout out to the Google hardware team and my friend and colleague, Kristen, who acquired the Google Home devices for us as prizes. And the rest of the Magenta team, who are, you're going to be able to be presenting your work for the, I think it's the 3 finalists who win the contest are going to be able to submit and present work to the team. And they're doing just some really interesting cutting edge stuff. So that's a pretty cool opportunity. And feel free to reach out to me on Slack if you have questions. I'll be ghosting in the background for a while on this workshop to answer questions as they come up. And also Stephanie will take it away in a second. But you can, if you want to ask questions either during or after, you can also put them into the office hours Slack channel, which Stephanie will be monitoring, as will Rachel and Taro, who are the other teachers, as well as myself, to answer your questions. So that way, if you have questions about the code or the libraries, we can help you. And without further ado, I would like to welcome everybody and welcome Stephanie to help start sharing with the rest of us.
Awesome, thank you. Thank you, Nikki. I'm just gonna start by sharing my screen. All right, and I linked these slides in the chat as well. So hi again, and thank you for introducing me, Nikki. And thank you to everyone for attending this workshop, the last in the BitRate series. We'll be covering a lot of ground and touching on many different topics throughout the workshop in a very limited amount of time. So like Nikki mentioned, while our time tonight is really short, I'll also continue to monitor the Slack office hours channel to help with any questions you might have the rest of the month, and provide a link at the end of this talk for anyone who'd like to schedule time for one-on-one support. So again, here's a bit.ly link to the slide deck at the bottom right. I've pasted this link at several other key points throughout the presentation in case you miss it here. So just a little bit about me and my art practice before diving in. I'm a multidisciplinary artist and experience designer. I'm also one of the instructors of the Creative Code Immersive here at Gray Area in San Francisco. And in my art practice, I tend to make sentimental art games and playful tactile installations that respond to emergent and speculative issues and that explore economies of care and communication. Technically, I currently specialize in building interactive systems that use digital, physical, and interpersonal mediums to create shared space. And I'm an artist in our community with a deep appreciation for tools like ML5. I've even used this very library in several public art installations over the past few years. Like this interactive installation, CollabCom, which was developed as a physical and audio-visual tool facilitating collaborative composition, communication, and the physical exploration of sound and music. Let's let it play for another couple seconds. And this installation, what the camera sees, which is an exploration of computer vision, video editing, real news media, and surveillance technology. In this installation, pose tracking, facial recognition, and image compositing tools are joined by an AI filled with stories of spies, criminals, and secret lives. This playfully creepy experience imagines a not too distant future where your expected value and risk to society are constantly calculated by systems that are impossible to question or correct. And this one from earlier this spring, a virtual interactive work on the topic of empathy, outrage, and the internet. These are all projects I've worked on that have incorporated this very library in a core way, and just a few among many examples of what you might be able to do using the tools I'm sharing with you tonight. So I'm really excited to be here sharing in this workshop with you, and even more excited to see what you all will make this evening and throughout the remainder of this month. Speaking of, if you're somehow watching this workshop or recording, but not yet aware, this workshop is again part of a hackathon or a series spanning several weeks. And it's intended to be a gentle and tactical introduction to ml5, which is one among many tools out there for doing some form of machine learning on the web. I'll go into this a little bit more in later slides, but I'm especially excited about ml5 and how one of its core guiding features is accessibility. So with that in mind, this workshop is also geared toward being as accessible as possible. It's not going to be a deep dive into how to train your own models, nor into research paper topics beyond the scope of what is covered in the library. What it will be, however, is a friendly, practical, and hands-on introduction to how to get set up and running and how to approach using ML5 and its models for new creative projects. There aren't many prerequisites, though I'll be referencing ml5.js, which is another creative code library, and we'll assume some familiarity with introductory programming concepts using the command line and the JavaScript programming language. If you at any point feel lost, please don't hesitate to post questions on Slack in the office hours channel, which is being monitored by me and the other instructors, or send me a direct message. We're all here to help. So here is our manifest for today's workshop. We'll start by sharing a few related projects that use machine learning in some way, and projects that use ML5 specifically. We'll then go through a brief intro to several core machine learning concepts. I've tried as much as possible to remove or define any jargon that might come up in this workshop, and front-loaded defining many of the terms that I might throw around in the first part of this workshop. We'll then have a cursory review of ml5.js and ml5.sound, just enough to get you familiar with the program flow, structure, and a few capabilities of the ml5 sound library. And like Nikki mentioned, on this topic, Rachel, one of our other instructors, facilitated a really wonderful workshop that goes more in depth on how to use this. I highly recommend checking that workshop recording out too, if you haven't already. After that, we'll have a short break, then a guided walkthrough creating a simple gestural instrument together that you can customize during or after this workshop. Finally, we'll go through a partially guided micro project of your own design, talk a bit about training and deployment, and close out with a few additional resources. Throughout this workshop, I'll also introduce a curated selection of pre-trained models packaged up by ml5.js that you might want to use for your projects. The goals by the end of this workshop will be, first and foremost, cultivating greater familiarity and confidence in starting your own project using this library, and hopefully a small scoped project designed and potentially even completed in its simplest form. So next, I'm going to share a few projects that I think you'll find relevant. All these projects use machine learning in some core way. So this is Imaginary Soundscape by Cosmo Inc. and now Tokui. I'm just going to start playing this while I just kind of describe what it is. And there's no sound at the very beginning, so that's expected. So Imaginary Soundscape is a web-based sound installation where viewers can freely walk around Google Street View and immerse themselves into imaginary soundscapes generated with deep learning models. So I'll just let this play through for another minute or so to give you a sense. And this is Giorgio Count, an experiment built with machine learning that enables you to make music with a computer just by taking a picture. It uses image recognition to label what it sees, then it turns those labels into lyrics of a song. These are two projects that were created with accessibility at its core. The one on the left is a simple musical keyboard, and the one on the right is a sampler. You can play both with your face.
One quick request to increase the volume of your mic.
Oh.
I can hear you, but maybe they were saying I don't know if someone mentioned, Manuela, that you wanted her voice over the video or just in general? I don't know.
Oh, I think maybe I can, I'll turn down the volume of the video.
Of the video.
Yeah.
If you're going to talk over it, otherwise just like let it roll.
Gotcha. Thank you, Nikki.
Cool.
Cool. So these are two projects that were created with accessibility at its core. So the one on the left is a simple musical keyboard, and the one on the right is a sampler. You can play both with your face, body, mouse, or keys. And all of these examples in the slide deck, I've also linked to them. So if you wanted to try them out yourself, I highly encourage you to do so. And this is one project that uses a model called PostNet, which we'll talk about a bit later. This project, Semiconductor, allows you to conduct your own orchestra in the browser by moving your arms to change tempo, volume, and instrumentation, also using PostNet. So I'm just going to play this video and let it run all the way through. I really like that one. And here's a composite screen capture from 4 projects that use ml5. So in the top left is Sound Capture, a project by Jingyi Zhou. It's a motorcycle game generated by your voices, built with the pitch detection model in ml5.js. Irie Flies by Feng Yao is at the top right and is a game played with your voice. On the bottom left is Body Beat by Vibra Theo, a game powered by PostNet where you can play the rhythm with your hands and a webcam. And at the bottom right, Pong-ML, which is the game Pong, controlled digitally with your body and a webcam. So I selected all of these examples specifically for 2 core reasons. One, of course, they all use machine learning, and in this last slide, ML5 to power the interaction. And 2, there's some variety and overlap between which models are used and how they're used. Several use PostNet, some use pitch and sound detection. Many of them feel game-like in some way, are physically interactive controllers in a way that is less conventional for our virtual selves. And for the ones that do use the same model, they use them very differently. There's so much you can do using the models ML5 provides right out of the box for you. So much about working with this library is really pairing interactions with unique context. Similar building blocks can be conceptually expanded into many different directions. So I brought up some jargon a few moments ago. This is where I'll hopefully answer for you, what is machine learning anyway? This slide is essentially a very brief intro to some core machine learning concepts. So machine learning is essentially a strategy for teaching computers how to make sense of data, how to learn patterns, and how to perform tasks without being explicitly programmed. I once watched a great talk by Dan Schiffman, creator of The Coding Train on YouTube, who provided a really simple yet clear example of this, which I'll paraphrase and share with you now. And here's also an image to illustrate this. So imagine you have several shapes placed on an XY grid. There's a boundary that separates what is classified as a left shape and what is classified as a right shape. Explicit programming would be specifying some logic by which to determine its class, such as if the x coordinate of the selected shape is less than the x coordinate of the boundary line, it is classified as a left shape, otherwise it's on the right. This would not be considered machine learning. Machine learning would be more like if you have lots of data of shapes and their labels left or right, and with enough data, you can cultivate a model that can predict the category of the new shape. Both of these solutions would work in this very simplified example case, though machine learning really shines for more advanced tasks, where explicitly programming this determination would be a lot more challenging or potentially even impossible to manually do well by a human. In those cases, it would be far more effective and efficient to help the machine develop its own algorithms rather than have humans specify every single step. So when we talk about ML5 and machine learning, nowadays it's hard not to mention deep learning. This topic is somewhat beyond the scope of this workshop, so we won't go that deep into the inner workings of deep learning tonight. But if you're interested in this and want some guides for where to begin, please do reach out after the workshop. What I will say now is that deep learning is a form of machine learning. It's a specific method that has found success in the most recent decade of machine learning, in part due to the increased availability and accessibility of compute power. Deep learning enables you to make models with way more weights than non-deep machine learning. These weights help define how the model works, which also makes it way more flexible and capable of learning incredibly complex functions. A single deep learning model might have thousands or even millions or even more weights. And this would, as you might expect, take up way more data to train, store, and load up. The ML5 library under the hood packages for you many pre-trained models that use deep learning. So it's incredibly powerful, though it might take some time to load up, which you probably notice as we go into our labs later on tonight. For many of these examples, it could take as long as a few minutes before the model is loaded fully, depending on your connection speed and the size of the model being loaded on your machine from the web. So I mentioned models and weights a bunch just now. Models are essentially, models are essentially internal black boxes. All these black boxes have a set of internal model parameters that define how they process information they receive and how they output results. These parameters are also called weights. And weights are derived through training from data. So when creating models, you first define the box itself and what the parameters are, and then you use a lot of data to incrementally find the best weights. Anyway, this is a lot of front-loading some terminology. Practically speaking, ML5 has provided access to a bunch of really great pre-trained models for you already. And for many of these ML5 features, there are even more ways to select models to optimize for speed or accuracy without really going into all of these other like foundational concepts. But I wanted to put this slide here just to kind of give a little bit more background into this topic. And lastly, since I mentioned training, we won't go into training very much today, with an exception of a very, very brief slide near the end. I want to plug here, though, that ML5 also provides ways to provide your own data and train further to get weights that work even better for a specific problem you might have. So I don't expect that to be necessary just yet for us here, but it might be good to keep in mind as you continue working on your projects throughout this month and beyond. So what is ML5? There was a lot of foreshadowing in the previous slides. ML5 is a JavaScript library for machine learning on the web. ML5 is largely TensorFlow.js with additional functionality that abstracts away low-level things like managing memory and pre-trained models, and with the goal to make things you do with TensorFlow.js more accessible and easier to experiment with. TensorFlow.js is a JavaScript adaptation of TensorFlow, which is a powerful Python-based machine learning library. We'll only really work directly with ML5 for this workshop, but I want to mention that there are many different libraries that have functionality for machine learning tasks. So Keras and PyTorch are a few others that are also popular. I mentioned pre-trained models a few moments ago as well. So one thing I really love about ML5 is that it provides access to machine learning algorithms and pre-trained models in the browser. As we'll see shortly, it really only takes relatively few lines of code to integrate it into a simple project. One thing to note about using these pre-trained models, however, is that the existing models are aware of a fixed number of things. So it's very important to know what is in the set of what it knows, such as all of the labels and classes. And in the event that the pre-trained model is insufficient in some way, you can totally customize and retrain it further on data of your choosing through a process called transfer learning. And lastly, ML5 is heavily inspired by processing and P5.js, sharing focus on accessibility. It is very compatible with P5, though it can be used without P5 too. All right, so now that we've covered some foundational topics, let's get set up. So again, in the bottom right of this slide is a link to the workshop slides if you missed it earlier. So for this workshop, we'll be working through some examples that use ml5 with p5.js, another open source JavaScript creative coding library loosely based on processing principles, but written for the web. So Rachel facilitated a great workshop last week on this topic more in depth, but for this workshop, I will go over just a few core concepts that will help you understand enough starter code and subsequent examples. So first, P5 uses a Cartesian coordinate system with the origin in the upper left corner of a 2D canvas. Here's a diagram I got from the p5.js docs. And in our walkthrough example right after this segment, you'll see why I brought this up. To work with P5, you can use the P5 web editor linked in the slides or your local machine. So in the latter case, you'd need a simple HTML file setup that imports or contains both your P5 sketch and the p5.js library, also linked in the slides. The web editor does that part for you, so you can start working directly inside the draw and setup functions that it provides. The P5 library can be downloaded or accessed online via a content delivery network. The two main functions, among others, are setup, which runs exactly once, and draw, which runs once every frame. There are other functions too, like preload, that you might want to use for other tasks. These are all basically functions provided by P5 that are for control flow structure. Users define what's in the functions, and the sketch calls setup, draw, preload in the manner specified in its own source code. And there are other functions too, like those relating to user events, for example, mouse pressed and touch started. The last general points I want to mention here are that you can change the frame rate, that you can change the behavior of the draw loop. So for example, by calling no loop in the setup function, the draw function won't execute every frame. And lastly, that you'll likely want to start with creating a canvas in setup. Usually the first thing I do when working with any sketch is create a simple canvas with a background, and then try to integrate in some user input, such as a camera or an image or a sound. So these next few slides are adapted from the quick start section of the ml5 docs. Before beginning, you'll need a text editor such as Sublime or Atom, a web browser, and your command line or terminal. You'll also need to have Python installed, which should already be installed on many Apple computers. And if you don't have a MacBook or a Mac computer, then you might need to install it yourself. To get started, what you'll likely want to do is download and open one of the boilerplate ML5 projects, or alternatively paste one of the single file quick start options into a new index.html file. I provided some links in this slide that will direct you to exactly where these files can be found online. And you could also probably somewhat easily find them by just looking at the ML5 quick start online as well. So don't worry about doing this right now, though. I'll provide additional custom starter code for later activities. This is really just to provide an overview of if you were to start fully from scratch later and a reference point for the future. And here is an example from one of those links that uses P5 as a script put directly into the HTML file. So again, don't worry about doing this step just yet, but I just wanted to pull this up so you can see a little bit of what that looks like. So once you have your starter code set up, the next step is to try running a local server using it. So you use your terminal to navigate to the directory containing your saved files. Assuming you have Python on your machine, start a simple server with one of the following commands, depending on whether you're using Python 2.7 or Python 3. If it runs successfully, some text should pop up saying serving HTTP on and a specific port. You should then be able to navigate to your local host at the port specified using your web browser. In my case, in step 3, I specified using port 8080. So in step 4, I'm going to use that same port on my local machine in the browser. I've provided some sample commands for you here as well for reference, highlighted in yellow, and docs at the bottom for installing Python if you don't have it already. Okay, so now let's talk a little bit about sound. There are many, many libraries you might want to use to generate or play back sound, like tone.js, which some of you may already be familiar with from the earlier workshops. The one we'll touch on and use together here is p5.sound. p5sound extends the p5.js library with web audio functionality. The docs are interactive, and really a lot of this material is best experienced directly. So I'll just very briefly mention 4 capabilities and some special things about them. The P5 sound library supports, among many functions, input, playback, analysis, and synthesis. A few interesting notes. So sound playback can load and play sounds, as you might expect, but it can also do cool things like pitch shifting. The synthesis functions enable the creation of waveforms, control the amplitude and frequency of those waveforms, and allow you to specify the type of oscillator. And the envelope functions enable customizing used sounds, can make sounds like various instruments, and can connect to oscillators to further transform the sounds produced. The last thing I want to mention here is that the P5 docs are very interactive and directly editable. I'm going to share a very quick demo of that to show you how you might explore it for yourself later. So I added this slide because this is something that I didn't realize was a capability in the docs until like somewhat recently. And I think it's kind of cool that they let you explore the example code that they have already and actually change bits of it and try it out. So in this example, I had an oscillator of the type sawtooth, and then I changed that to sine in the docs, and then I executed that. Okay, so that was a lot of foundational material. So in the next sections, we'll do a guided walkthrough together to create a simple gestural instrument. Have time after that to work more independently and touch on a curated set of pre-trained models available in the ML5 library before closing with deployment, training, and additional resources. So at this point, I'd like to invite you all to take a 10-minute break. We're actually a little bit earlier than I had thought we'd be. So, but let's just take a break now anyway. And if you'd like to get a head start on the next activity, please clone the following repos. So I have 2 links here to GitHub repos, one for the completed demo of the next activity and a starter project for that same demo that walks through the first 2 steps. And then after that, you'll be able to follow along. And again, these links will be available in the next few slides too. So please take a short break. And maybe let's come back at 5:40. Okay. And I'll just check the comments during this time. So welcome back, everyone. So we got some questions in the chat over the break, and I'm going to do my best to try to answer them through the activity of this walkthrough. So I know I provided you these repos, these demo repositories to clone right now. The intent wasn't for you to really dig into it and understand everything yet. The next activity is to explain like every single piece of that and how to work with that. And then after that, during the next break, I'll try to check in with everyone who is having troubles getting it to work. Cool. Okay, so browser cache that was causing the issue. Cool. Awesome. All right. So this next segment will be a guided walkthrough of creating a simple gestural instrument together. So for illustrative demo purposes, I will provide prompts for each step and walk through how I'd approach them with a simple, specific project in mind. So a mouth instrument. This will walk you through my general approach and process, which is to design, get something simple running, view the results, then iterate on all that. So again, the link for the repo with the starter files and the completed demo at the bottom right. So as I mentioned, I'll be walking through steps using a specific project that utilizes one of ml5's packaged pre-trained models, specifically Face API, to create a sound interface triggered using the mouth. These are the features that I've selected. I'd like to trigger sound with a simple and natural gesture of a mouth opening and closing. I'd like to do something kind of unexpected with that. To keep the P5 part of this simple, I'm going to do a grid of only 2 sounds, 1 sound per side, with a boundary line dividing the 2 sides. And I'd like the position to be what determines which sound is triggered. So the repos, the very top link of the repo of the starter files is what I'd like you to clone at this point, or to have cloned at this point. And this will take you up through step 1. I have this here at this step just to kind of shortcut some of the initial typing. I'm providing this to really give you the option of whether to type out and follow along after that point, or to watch and come back to it later. I've also provided a completed project repo for you to try out. So I encourage you, if you're just starting out with ML5, to generally follow along to the best of your abilities. And if you're more advanced, to try adapting the code or project as we go along to be somewhat or even very different. Whether it's using a different body part, different P5 effects, or even a different pre-trained model altogether. So for this demo, we'll be using the API to Face API.js that ml5 gives us, which is a wrapper on top of Face API.js, a JavaScript library that allows you to access face and face landmark detection results. The underlying Face API library also provides estimations for expressions, age, and gender, though this is not yet supported by the ml5 library. So one note here, a caveat to using these packaged models. These are really cool and powerful tools, but often are really close to repackaged research projects, which don't always tell you all the things you could get and don't always provide you with all the access that you might want. And oftentimes the docs may feel lacking in some way. You might want to look at libraries that ML5 is built on top of, such as the Face API.js library docs in this case, and even then libraries that is built on top of, since that too is a wrapper on top of some research level content of various models. And then potentially even the underlying research papers themselves. So that's kind of an intense process that can be really informative and useful. But for our purposes today, I provided another method to explore your results and bypass some of the rabbit holes you could dive into. Okay, so done with that caveat. Now a quick acknowledgement. Several of the next slides are loosely adapted from the initial setup structure recommended by the ML5 docs, which I encourage you to look at as well. A few of these earlier steps are different in key ways from those initial ML5 setup docs, so it might be interesting to try out and compare. This walkthrough will be my effort of really breaking down this process as much as possible. So first, as a preliminary step, we want to set up a few starter files and try running them with a local server. So we'll start here with an adapted starter example project that already has P5 and ML5 both imported and set up at the top. There are many different ways to set this up, and I chose one that felt simplest. So this is our index.html file that we're starting with. I added some very minimal HTML and CSS styling. The important things to note here are that I'm importing all the libraries I'm using, so P5, P5 sound ml5, and also importing our sketch script, which will pull in all our P5 code. Much of this index.html file will remain unchanged throughout the rest of this walkthrough. And again, don't worry about typing these first steps 0 and 1 out. This has all been provided in the starter repo that you cloned earlier. And I've also provided the link here again if you've missed it before. And if you are working with Glitch, then I'm going, if you are working with Glitch and have some challenges with getting this to run, then I'll try checking in with you when we a little bit farther down the line. This is what the complementary sketch.js file looks like at the start. So I added some explanatory comments in the code. Usually you start with setup and draw, and I put in preload as well, since oftentimes you'll want to preload images or your models themselves in preload. Preload is executed by the sketch before setup. Next, we'll set up the canvas and then the video capture. Instead of live video, you can also use another form of media, like an image or a sound, depending on the model that you're using. We'll set up loading and playing sounds in the later steps. At this point, I'd like you to also clone or copy the code from the repo provided at the link above. Again, you can copy or clone this repo and follow along if you haven't already, or adapt for your own project at each step. Briefly, just to walk through the code a bit, the first 2 lines initialize video variables. One to reference the capture for later use, and another that I put in to enable easy toggling of whether you want to view the video feed in the sketch. I've set this to true for now. I defined a draw capture function with a partial transparency up top that I later call in the draw function. I'm leaving preload for now and alone for now, and in setup, I've created a small canvas and configured and started the live video feed. In the draw function, I clear the background every frame at the top, and I call the push, translate, scale, and pop functions to flip my video feed so that it looks like a mirror. This specific code is structured in this way because of P5's Cartesian coordinate system with the origin at the upper left corner. So within this transform chunk of code, I have a conditional that says if show capture is true, then call draw capture, the method, which will return the current video frame every time the draw function is executed. After this, I encourage you to try starting your local server and see if you see yourself in the sketch. So that's all it should look like right now, is a very simple video feed. So from here on, the next repo will be the completed project. So if you'd like, please feel free to just add the additional content at each step, but that's not mandatory at all. So step 2 is to define a few global variables. The new variables here relate to ml5. So classifier, detections, and a detections options constant up top. Exactly how these will be used will be shown in later slides. But for now, what you'll need to know is that this is defined globally to have global access across all functions in the sketch to whatever data is found to them. Next, let's load or preload the classifier. I think the hello-ml5 example in the ml5 docs preloads the classifier since it only uses it on a static image. Since we're initializing our classifier with the video feed along with options and a callback function, we're putting the classifier instead loading up in setup. This is because we don't start up the live video feed until earlier in the setup function. The callback function we define and use in this step is model loaded, passed as a parameter to the face API initialization function on line 49. This function is called once the model is loaded, and at this point, we'll just print to the console string, model loaded. Lastly, you might notice here that detection options defined in step 2 is used on line 50. You'll likely want to customize these options further, at which point you need to reference the ml5 docs and potentially the underlying face.api.js docs. Step 4 adds a bit more code to the model loaded callback. So using the classifier we defined and initialized in prior steps, calling detect will run face detection on an image or video, live video in our case. We pass a callback here too, got result, which will handle the results of the detect function executing. It'll pass in errors and results as parameters, so we've set up our structure to match that. Next, we'll define the got result callback. So in this step, I've set, as we're defining the got result function, I've set it to display an error in the console if there is one. Otherwise, to do something with the results we get. I added a few debugging comments to help. Feel free to uncomment them as needed or leave them out. And I also added a line to bind our locally scoped results to our previously defined globally scoped detections variable. So I do this here because I later will want to use the most recent set of results each frame in the sketch's draw function. Finally, the last line of this function, I call the detect method again here to keep this going. You could also potentially call detect and draw since draw executes every frame. But you very likely want to do some special handling if you opt to do this instead. This is because, especially for larger, more complex models, they will return results at a pace that isn't well synced with the draw's frame pace. What that means is, without special handling, you may be repeatedly calling the detect method every frame before getting results returned from the last times it was called. So I recommend for a learning experience just trying this out anyway and observing what the outcomes are and how to work around them. So at this point, we should have enough to start our local server again and see something more interesting in the browser. I've provided an image here of an example command to start the server and what your sketch should look like behind it, or might look like behind it. So it might appear as if not much has changed. However, if you open your developer tools console, you can start spelunking into the global variable results. So we know the docs return. We know that we get we know from the docs that we will get a face and its landmarks. So how do we actually access all of the data that is returned in JavaScript? And if we want to use the landmarks, which numbers correspond to which features? So you might be able to find this out via the docs. But this can be a really nice and simple exploratory shortcut. So at this point, I want to encourage you to explore the structure of your results. Make sure first, though, that the webcam feed is playing and there aren't any unexpected errors, and also that the model loaded properly. So if you have any challenges or questions about accessing the developer tools or console, I added a link in the title of the slide that could be helpful. And please also don't hesitate to let us know in the chat or in the office hours channel. So for the next 10 minutes or so, I'd like you all just to kind of dive into what you get from the Face API results and which we found to detections, and just get a sense of like the structure and how you'd work with that. And in this time, I'll also check the chat again and try to help people who are who might be stuck with some of the earlier steps. Okay, so there's a few questions in the chat already. So Steve Blair asked a really interesting one here. So Steve, I'm just gonna share your question if you don't mind. He said, I noticed we're making a canvas and fitting the video into it, and I looked a bit squished as a result. Is there a way we can get the video dimensions, then use that to ratio to create a canvas? So I think in one of the earlier slides, so in the very first, the starter example code, I put in, I specified the size of the video. Let me actually go back to that. Hold on. Okay. All right. Okay, so in lines 29 and 30 on step 1, I wrote a comment that says set video size to width and height of the canvas and hide the video feed to render later in draw. So basically, I did this partly because I think for my machine and for many, I think it should be okay for many similar MacBook machines, then these are like the proper correct dimensions. But I think that there are functions in the P5 docs that will get you your resolution. I think they're like under pixel or something like that. I'll see if I can pull those docs up for you too. Sorry, I will try to keep this super simple, so that's why I didn't actually add a lot of that extra code. But I can go look that up right now. Thank you for asking that, Steve. And so another 5 minutes to continue spelunking or catching up. And again, no pressure to type this all out. Feel free to just play with the completed demo or keep expanding the starter demo. Okay, so question steps, slide steps 2 to 5 are showing code we should be adding to sketch.js. So I'm going to go back. Oh, cool. Yay for glitch. Okay, so sketch 2 to 5. Yes, that's correct. That's a really great question. So I provided the starter repo, and you could also type it out if you really wanted to. And then from there on, feel free to type this all out or copy it from the completed repo, or even do something entirely different that is sort of just loosely modeled on this structure and process. And Ted Peterson, I'm going to share your question as well. So I get this warning with a completed demo. It works fine, but fan on Mac and overdrive. So I'm going to try that again on my machine. I've never actually encountered that that warning. Yeah, is anyone else getting that warning that Ted brought up as well? Like Ted, I can look into this during the next break as well. But it's not something that I've witnessed yet. Cool. Okay, so 2 more minutes to kind of get caught up and continue spelunking into this data. And so as you're kind of digging into the results from the detections of the Face API model, then keep in mind like what we actually want to do with it. So for my example, specifically for the demo project, I wanted to determine to trigger sound if the mouth opens and closes. If mouths that are detected open and close. But if you want to do something else, like trigger with your hand position or whatever, then, or I guess it's Face API, so it wouldn't be hand position, but trigger with like your nose position or something like that, then you would want to do something a little bit different. Okay, I'm just going to go back to this slide. Cool. So 6:05. So next steps. The remaining steps are very specific to the demo project that I described at the very beginning and mostly focus on expanding what is rendered to the canvas and what and how sounds are triggered. And all of this will happen in sketch.js. So in the last step, we went over how to spelunk and explore the structure of results. Here, I've written a simple debugging function that renders the numbers and relative positions for each face landmark. I chose to do this because it's a simple and helpful visualization, and because for face landmarks, there are several models out there that number differently. And it was a bit challenging to find a representative pre-existing diagram that maps landmark position in this API to their corresponding numbers. In preparing for this workshop, I actually tried to see in the docs if I could find that very easily, and it was just not, this wound up being just a lot easier. And I like that it's a good example of just sort of how to figure it out if like there just aren't really accessible docs to begin with. So this is rendering like basically the landmarks that are drawn, so numbers at each point, and I've set show capture here to false. So that means like the feed, the webcam feed underneath that is not showing at this point. So just walking through this function, the draw numbered landmarks function, once we first get detections, which are return results that we saved into our global variable, we then iterate through those detections and draw to the canvas the number at the specific XY position of the landmark. We then call this every frame in draw. This slide is all about setting up the grid. So I have debugging landmark still there and set show capture back to true. It was false in the last slide again, which is why you didn't see a live video image in the screen capture there. So the new function here is draw two sides. It's very much just P5, and I've annotated most of the lines. So I'll skip explaining this very in depth. We'll call draw two sides every frame in the sketch's draw function. And if this feels very unfamiliar, then I'm happy to go into it a little bit more in depth during independent time or during a break or during office hours as well. So step 10, next is loading the sounds. So we have a couple new global variables for binding loaded sounds to. And in preload, we use P5 sound to load two sounds bound to those global variables. So I just called them sound 1 and sound 2 for simplicity's sake. I'm selecting short sounds for now, and I'm doing this because when I'm working with P5 sound, if you use a longer sample, you might want to have extra handling of determining, you might or you might not want to have extra handling of determining if the sound is currently playing before you play it again. Or maybe you don't care about that or you want it to play on top of each other. So for simplicity's sake, I just chose really short ones to kind of bypass that whole issue. But if you have questions about going through the process of using a longer sound, and handling it in a particular way that is a little bit more challenging, then please feel free to reach out at any point. So step 11, connect detections to sound. So this is the penultimate step. Here we have a few new global variables near the top of sketch.js, which relate to the trigger boundary and thresholds. There are many ways to write this. We initialize a middle x variable to later define the boundary line as half of the inner width of the canvas in the sketch's setup function. We define the threshold by which to consider a mouth open to 10 pixels and set the last mouth open bool to false. So that threshold is just something that I picked after testing. So you can change this to whatever, or again, use different points altogether. We also have two new functions here that use these variables. So isMouthOpen, which takes a mouth top point and mouth bottom point as parameters and returns a Boolean about whether the Euclidean distance between the points exceed our defined threshold, and TriggerSound based on pause, which takes a target point and determines whether that is on the left or right side of the border, and triggers a sound that corresponds to that side. So again, this is all very specific to like the demo project that I had in mind. So you can totally adapt this or scrap this all together and do something else from a couple steps ago forward. So interesting thing here to tie back to our machine learning concept overview earlier. We're explicitly programming this borderline determination. So this isn't using machine learning here. We're really only using machine learning to determine face landmarks and their positions, and then we use that in the code. Here is where we use those functions. This is all wrapped in an if detection statement at the top of the highlighted code block, because we only want to run this block if we've already received results. I've commented out the draw numbered landmarks function right below that, since we no longer need it. And below that, we have a loop that iterates through the detections and selects the top and bottom mouth points, which I determine using the debugging functions in step 8, where I drew out or rendered out all of the numbers corresponding to the points. I then used the functions defined in the step before this one to determine whether the mouth was closed and is now opening this frame and what sound to trigger. I finished this chunk by setting the last mouth open bool to whatever is mouth open returns. And finally, drawing mouth. So this is all just a style thing done in P5. I won't go into this much, but please feel free to dig into this and reach out if you have questions. So I added this in part because I wanted something that was visually clear, and also if I wanted to, like, if I or you wanted to eventually turn show capture off and not actually see your face and just see the trigger points, then this would help do that. And also, I like this because having a function like this, because it tells the user without explicitly having a pop-up that says your model is loaded, that your model has done something. So like in this case, once the model is loaded and it's starting to have a detection, then you'll see pink lips or magenta lips in this case. And that's a sign that it's running properly and it has already loaded. And this is where the draw mouse function is used. So inside of the push pop transform code segment, so that it aligns with the mirrored live video capture. Oh, and then one other thing to know, I put draw two sides here too. It doesn't really matter if it's inside of this transform chunk. It's just mirroring it, but like for our purposes, it didn't really matter. But it didn't need to be in there. That's all I wanted to bring up about that. And finally, this is just a screen capture of what this all looks like. Of course, you'll want to run this to try it out. So I recommend cloning this repo and running it locally or trying it live in the link provided in the slide. Wait a bit to see a mouth rendered, which will be an indicator that the model is loaded. Then turn up your volume a little bit, move your head position, and open and close your mouth. So since the models that Face API provides are kind of heavy, they're really powerful, but they're also kind of heavy. It might take a minute for all of this to load. So I'll give folks just like another, the next like a few minutes, or maybe 3 minutes till 6:16, just to try this out a bit. And I'm going to check the chat again to see if any additional questions came up. So now, once you have it working, like I want to, oh, CCPI is not loading. Okay, Siash, I'm gonna go check your issue. Also, we'll check in a couple minutes. But for everyone else who already has it working, I encourage you to spend this time sort of modifying this demo or whatever demo you started working on earlier. So maybe another, like until 6:20, continue adding to it. So actually, the next few slides will go into this a little farther. So I'm just going to go up to that, and then I'll go back to answer some of the other questions. So just a quick note at this point. If you see an error in the console, it's probably this. So no need to be alarmed. The sound should still play. This is a reported issue in the P5 sound repo that will very likely be addressed soon. But it seems to be non-blocking currently, and the sounds play just fine for our purposes. And once the issue is resolved, then the code that has been provided should be perfectly fine. All right, so I'm just going to discuss going further and then give us all maybe 10 minutes to kind of just play around with this and keep expanding it while I answer some other questions. So cool, we did it. That was a whole lot of material. So if you get this running on your local machine or any other simple project on your local machine or on Glitch, I encourage you to expand on it and go farther. Here are a few ideas to get you started. So you can iterate on the visuals, you can add more sound, you can adjust sound parameters, change trigger gestures, change the models, add another model and combine them, handle edge cases, and so much more. And there are also many more examples in the docs, which I've linked at the very bottom right. Okay, so let's spend the next 10 minutes or so continuing to expand this or expand whatever it is you were working on. And then I'm going to go see if there are other questions in the chat now. Okay, so let's spend another 5 minutes continuing to adapt what we have. And if anyone has gotten, has taken this time to go farther in whatever direction, I'd love to, and if you're comfortable doing so, like please do share that in the chat or on Slack, but no pressure. Okay, so Suyash brought up a very interesting point. About how the models or the project sometimes runs terribly slow. So I think earlier on tonight, I kind of mentioned that like many of these deep learning models have millions and millions of weights. And the more weights that you have, the more flexible and powerful your models are. But that also means that it just takes a lot more power, it takes a lot more time for it to complete and return a result. And so of course, if you have or not of course, so that will also mean like if you have a more powerful computer to begin with, then that will go through that process more quickly than if you have one with less computing power. So that might be the issue if it's running really slowly. So on that note, though, hope is not all lost because I only very briefly touched on this in the intro, in some of the intro slides, but there is a lot of room here for optimization. And I'm not even talking about like deep, transfer learning training or like that sort of optimization. I just mean in terms of like, at the level of picking and choosing which models you use. And for the models that ml5.js provides you out of the box, those actually also have options that you can dig into that will like allow you to specify if you're using the tiny model or the large model that's very powerful. So there are many trade-offs here. So the tiny model will be probably faster to load, probably faster to run, but probably also less accurate and less flexible. The larger model, if you can, have the compute power to actually run it at the speed that you need it to run at, will be good in its own ways as well. So I kind of, if you're having any speed issues, I would dig into the Face API docs in the ML5 docs or the Face API.js docs to kind of see like what are the different types of models out there and just try them out. So you could check what the sizes of the models are, but the size is not the only thing that you would make a determination on, because it really is evaluating and balancing accuracy and speed. And so even if it is really fast, you wouldn't want to pick something fast that just returns a really crummy result. So what I recommend is trying out like different ones, changing some of the options and specifying specific models for your use cases, and then kind of discerning or determining which ones could work and what the source of the issue might be. So this is only just one answer or a couple of answers to the question of why is it running terribly slow, there are probably many, many other answers to this as well. But thank you so much for bringing up that really great point. All right, so it's 6:25 now. I'm going to go into the next activity, and then we'll have a little bit more time for independent work and kind of just catching up and going over any questions from the chat as well. Okay, so this whole next section will really be about guiding you through designing and building your own interactive instrument. So I'll walk through some steps for how to think about this and provide suggestions for how to get started. I'll also go mention a few more pre-trained models accessible through ml5.js that I think would be interesting to try using in this context. So during this time, I encourage you to post any questions that come up in the Hackathon Slack office hours channel and or in the chat. So a few starting notes about scale and scope. So first, start simple and get something running, then iterate and expand. With that in mind, here are some suggested approaches or optional constraints that might be helpful if this all feels like a lot. So use ml5.js for all of your machine learning. So I like this tip because ml5.js is intended to be very accessible. So not only does it abstract away a lot of the lower level details and issues that you would need to handle yourself in libraries like TensorFlow.js, which it's built on top of, it also means that there's a whole community around it. Many of the folks who are engaged with it, like Dan Schiffman, for instance, are also engaged with the P5 community. And all of that is around the core, a core principle that sort of enshrines all of these communities is really focusing on making it accessible for people who aren't machine learning experts or who are interested but not really sure where to start. My next suggestion, that's totally optional again, is to limit yourself to 1 or 2 models to start, and then iterate from there. To use p5.js and related, mostly because, again, accessibility, and there's just so many great examples and resources. And to start with a starter project from the ml5 repo. So I have a link here with a bunch of examples. So that's what they're there for, is to be a reference for you to kind of build on top of. And of course, sorry, I shouldn't say of course. There are also examples in the ml5 docs that are interactive as well. And some of them take a while to load. So if it seems like it's not working, just give it a couple minutes. Some of the text ones, when I was testing them out and preparing for this talk, took a few minutes to load. And I was just like, why is this not working? Because it was working so quickly on my computer locally. But it does, most of them or all of them should work. And then also explore p5.sound and ml5 interactively on the docs sites and in the web editor. So in some earlier slides, I kind of touched on some of the functionalities of p5 sound. So there's a whole lot in there that's really, really interesting to dive into and just to play with. So even if you don't have a deep understanding of sound synthesis and sound topics overall, there's just already a lot that you can do from a more exploratory perspective. And if anything, I find that coming at it from a less expert perspective with fresh eyes can actually provide really interesting, not solutions, but interesting approaches to what you might do that might be even a little bit unconventional, but really interesting because it's unconventional. So I really encourage you just to really dig into that. And again, the docs for P5 and P5 sound are, I think, mostly, if not all, interactive and directly editable. So very, very accessible and friendly. I also encourage you to dig into the library and consider new accessibility affordances with these less conventional controllers. So I kind of hinted at this when I talked a bit about p5.sound, but in general, ml5.js, yes, it's for machine learning. You can do training and you can use all these great models. But I think one really cool thing that that many of the examples I showed at the very beginning of the workshop had in common was just you have all of these models that you wouldn't expect to produce a certain result. So like we, you know, most of the models, and I'll go through some more in the next slide, so maybe I should hold off on this comment, but you'll notice that most of the models that I bring up are not sound models and are not like sound detection or pitch detection models, although I do bring that up briefly as well in a later slide. Many of the models are really like utilizing other types of interfaces or other types of features that you can tap into, which I think opens up the doors for so many potential accessibility, creative accessibility projects. Or you can start from a few conceptual themes or ideas and think about ways to make it relevantly fun, absurd, or unconventional using the tools you have available. So giving consideration to your target audience, intentionality, accessibility, space, and memory. And lastly, how to defy assumptions regarding all of the above. So this is actually what I often do in my own practice, although I find it fun to kind of just spelunk in and dive into one of the examples too. Okay, so but first, a little bit more about what ML5 has to offer. I think it's really helpful to know what the constraints are of the tools we're using first before thinking of what all we can do with and beyond these tools. I also feel these constraints can be inspiring and push us to think about how to work both within and beyond the boundaries of those constraints, and thinking about ways to circumvent or subvert expectations once we know what those expectations are. So the next few slides, I'll introduce a few more tools in the kitchen sink that is ML5. So this is just a little bit about PoseNet. PoseNet is a machine learning model that allows for real-time human pose estimation. PoseNet can be used to estimate either a single pose or multiple poses, meaning there is a version of the algorithm that can detect only one person in an image or video, and one version that can detect multiple persons in an image or video. PoseNet also outputs confidence scores as well, which are more probabilistic answers. So for example, how confident is the model that the blue box person on the right, or I guess in the center, is actually a person? And the answer is, I guess, 0.7 or 70%. Cool. Okay, so here are some additional works made with PoseNet. So I'm going to play both of these videos since we have time for them. So I really like both of these, but I'll start with this one. So this is Pom Pom Mirror by Daniel Rosen, and this is made with PoseNet. So this artist actually has many pieces that do something kind of similar with different materials. So I encourage you, if you're interested in this, this type of work, to just look him up and see what else he's made. So this next example that also uses PoseNet is Sidewalk Orchestra by Cristobal Valenzuela. This is actually one of my favorite pieces. Also, Imaginary Soundscape is another one of my favorite pieces that utilize machine learning models. Cool. Okay, so this is just a little bit about BodyPix. BodyPix enables real-time person segmentation in the browser. So a description from the BodyPix docs. BodyPix is an open source machine learning model which allows for person and body part segmentation in the browser with TensorFlow.js. In computer vision, image segmentation refers to the technique of grouping pixels in an image into semantic areas, typically to locate objects and boundaries. The BodyPix model is trained to do this for a person and 24 body parts, parts such as the left hand, front, right, lower leg, or back torso. In other words, BodyPix can classify the pixels of an image into two categories. One, pixels that represent a person, and two, pixels that represent background. It can further classify pixels representing a person into any one of the 24 body parts. I read an article recently about some folks who use this to do a color pop effect on images, and there are certainly many other possible directions and applications of this. In fact, I feel like, I'm not 100% sure, but I think that the virtual background feature in Zoom that we're using now, or that I'm using now, it probably uses something like this under the hood because it's separating me and my body from my background and then putting another background on a virtual canvas behind it. So I would not be super surprised if the Zoom virtual background stuff was using BodyPix. So a little bit about YOLO, which stands for You Only Look Once. YOLO is a real-time object detection system. YOLO's results provide labels, their confidences, and bounding boxes. And here's an image using the results of this model. So we have a dog, a bicycle, and a truck. And it seems pretty accurate. I don't know if that's a truck. I guess it is a truck. Cool. And a little bit about char RNN. So RNNs are a type of neural network architecture useful for working with sequential data, like characters in text or the musical notes of a song, where the order of the sequence matters. This class allows you to run a model pre-trained on a body of text to generate new text. So here's an example that I just ran in the ml5 docs examples. So if you dig into the docs, most of the features, most of the models that they provide, there's a section with usually at least one example that is interactive in some way. So as you're exploring in this next activity and beyond, I really encourage you just to start with, potentially just start with playing with some of these and getting a feel for how it works, whether or not you like it, etc. And also, since this workshop is around making instruments, I figured I'd include a few sound-specific machine learning models too. So ml5 provides access to sound classification that enables you to detect pre-trained voice and speech commands, and pitch detection, which estimates the pitch or fundamental frequency of an audio signal. Yeah, so I tried this out and it worked. And it's kind of fun to work with. Cool. And there's just so much more beyond this to explore. This library is also open source and maintained too, with its contributors continuing to integrate more pre-trained models into it. And you also, could try contributing to it as well. So in the future, I expect that there will be more and more of these pre-trained models integrated in, because really ML5, in my mind, it does provide helper functions for doing your own training, but I think the bulk of it so far at this point is really revolving around providing easy means to experiment and just get started and running with really powerful pre-trained models. So like the example, the walkthrough that we did together, that was 12 steps, but only there were only 3 or 4 steps that were actually hook in ML5, and the rest was get it set up and then finish it off with a visual thing that represents the data. But the actual using the model part is usually not that many lines of code because ML5 has abstracted that away for you. The main thing that you'll want to, one thing that you might want to think about though is just referencing the comment that Suyash brought up in the chat, that you will probably want to play around with the options, detection options, or I think that the different models call it different things, but the options will let you play with like confidence thresholds. So like at which point do you want to ignore the results, between 0.0 and 1.0, and other parameters like which specific models within a like category of model do you want to use, making the trade-offs that we mentioned and touched on before around accuracy and speed. So really, for this workshop, the goal is really just to kind of become more familiar with how to get it running, to get something running, and to get data from that. But beyond, I really encourage you to like also, start thinking about those optimizations somewhat, or start customizing and making those decisions specific for your use case. And then lastly, I mentioned earlier that some of the models might not be exactly what you want out of the box. And in particular, this really applies to like image classification and text generation. So, because PostNet is like, unless there probably aren't like body parts that it doesn't. I can't think of any body parts off the top of my head that it doesn't already capture. So PostNet probably like, I don't think you'd really want to continue expanding on it, but something like text generation, if the model is trained on horror novels, you're not going to generate a romance novel from that. So you'll want to further customize that. And similarly, if you use a deep learning model that is, like I think GPT-2 is trained on a bunch of Reddit posts, then the comments and like the type of content it generates will kind of be similar in feeling. So those are just some additional things to keep in mind once you get past this initial like getting stuff working together. Okay, so now it's time to dive in again. So a few hopes for this next section. So like I mentioned before, let's just get something small running. Even if it's only getting an example starter project loaded up and displaying its results in the console and then spelunking into it, that's a huge hurdle that you've just overcome. And then you'll have a stream of data that you can do whatever you want with after, with a little bit of JavaScript and P5 know-how. And again, for a deeper dive into P5.js, just doing another plug for the workshop earlier last weekend with Rachel, which is a great place to start. And also another goal is to just get some ideas going. So one of the goals that I had for this workshop is to just show a nice sampling of like the different things that you could potentially do or that people have done using many of these models. So this time is really to get you inspired and thinking about how you might engage with these tools in novel and exciting ways. And let's just overall learn more about new models. So there's no expectation that you complete a whole workshop project during this workshop. I just hope you'll round out this weekend with inspiration and more confidence as to how to approach designing, developing, and sharing a project using these tools. So I've set aside some time for you to start thinking about designing your own project and to dig into the library more yourself. So a few tips mentioned earlier if you're not sure where to start. Explore pre-trained models from the ML5 docs, try out some example starter projects. So there are several links here that could be helpful for that. And then think about how you might expand on them. And just start building with the tool and see if you can find an interaction that feels fun or interesting for you. And specifically for instruments and sound, a few questions. So how might you recreate an aspect of an instrument experience? How might you surprise with an unexpected interaction to generate new sounds? Many of the models shared, again, are intentionally not directly related to sound. And this is just sort of to get us to like think a little bit out of the box around this. We discussed many of the models packaged in ML5. And these are the ones I selected that I felt would be a bit easier to think about sonifying in some way. Though I really also encourage you to explore one of the other models there. And so for the next, let's take the next 10, maybe let's take the next like 15 minutes until 7 p.m. To just continue designing. So I put 10 minutes, but let's just do 15 since we have a little bit extra time. And in this period, if you'd like, I'd like to invite anyone who is interested and comfortable with doing an optional quick share. So share your design ideas in the chat. And this is a great opportunity to find collaborators for the hackathon and to share more about what you're excited about. So, so I know that like there are still a few weeks left in this hackathon, and for this project, hopefully, like if you have it really well scoped, then it should. It might still take quite a bit of time, but there's still time to find new collaborators. So I encourage you to make use of the chat, make use of the Slack that that Nikki and the rest of the crew have provided for us to continue meeting other people and actually working with them potentially. And then lastly, just a quick slide on starting small and starting building, a quick slide to say start small and start building. So get a starter example project onto your local machine. So again, either reference parts of the example docs to create new files, or start by cloning the ml5 examples repo. Get that running. So we went over this briefly on slide 21. So please review that for a refresher on starting a simple server if you would like a refresher. And minimally try to set up your sketch to print results to the console. So see slide number 36 for a refresher on accessing the console if you're not sure how to do that. And also please feel free to post any questions or challenges you have with any of these steps in the chat or on Slack in the office hours channel. And finally, investigate your results, integrate P5 components, and test, iterate, and expand. So let's spend the next 15 minutes just designing and exploring. Okay, so I'm going to pull this slide back up. And this time I'll check the chat and try to answer questions there. Cool. So now here's just a short block of time for further research and development. And again, please take a break as needed. So this is time to just kind of let everything sink in and time to continue expanding your core working starter project. So the last part of this activity was really to start designing, and now is time to continue developing or to start developing it and hooking everything in. And also at this time, please feel free to reach out in either the office hours channel on Slack or the chat here on Zoom. So the goals are for this, again, to become more familiar with the features of some of the pre-trained models ml5 provides out of the box and how to work with them, and to have a few approaches for beginning and working through implementing, creating a new project, cultivating some inspiration and initial ideas for creative ways to augment the core functionality, and getting something simple running that uses a pre-trained model successfully that in time you can continue building upon and expanding on your own afterward for the purposes of the hackathon and beyond. And also hopefully to meet others who are interested in similar things to learn from and build new relationships with. So at this time, please feel free to take a break as needed and or just continue working. And I will be available in the chat or on Slack to answer any questions. And just a quick sneak peek into the remainder of our time together. Next, we'll just kind of share a bit about in-progress projects and ideas, and then talk a little bit about training and deployment and additional resources and close out. And then after that, we'll just have basically the remainder of the time will be office hours and just working for whoever wants to stay and continue working on their projects. So for the next 10 minutes, let's spend some time doing a little bit of further research and development. So at this point, I'd like to invite folks again who'd like to share in-progress projects and ideas to do so in the chat and/or on Slack. I think, again, this is a really great way to share what you're interested in, to find and link up with others, to potentially expand and build with. So a few optional suggested talking points for sharing through your name or Slack handle, an in-progress project or concept from this workshop or for the rest of the month, whether you hope to participate in the hackathon, whether you're seeking collaborators and for what skills, and how you might expand on what you've started today. So this is really to kind of just share what you've been working on a bit or what you're excited about. And also, if you are still looking for folks to like start a new project with, this is a really great time for that. So, all right, so nearing the end of our slide deck, but I wanted to do a quick plug for Teachable Machine. We talked mostly today about using pre-trained models, though ML5 can also train models as well using a neural network helper function. So if you're interested in this topic, Coding Train has a good series on this. There's also Teachable Machine pictured here with a screen capture from the docs about how to use it. Essentially, you gather and group your data, click Train Model, and export your model to import into your project later. So I added a link on the slide to the project page docs and also to the Coding Train tutorials around how to actually use this. Last thing we'll go over today is deployment. So deployment is the process of moving code from one computer to a remote public host that allows other computers to access it. It includes all related activities that prepare your code to run in a specific environment. You do this so that you can get code that is only on your machine shared with the rest of the online world. So there are many tools you might consider using. I've listed a few popular ones here for static and dynamic web applications, such as Amazon Web Services or the Google App Engine, and GitHub Pages, which is what we will be using and we'll go over next. So here's a quick guide for how to deploy on GitHub Pages. So as mentioned before, you'll need access to your command line or GitHub desktop app and a GitHub account. The steps are to prepare a project, then to initialize a Git repository and commit your work, then create a GitHub remote repository online, logging into the github.com site, then linking your local repository on your local machine to this remote repository, and pushing your work from your local repo to your remote repo. I've included links for these steps on this slide too. And finally, you'll want to enable GitHub Pages and configure a publishing source. I've included a link for that as well, and a screen capture of basically the only step needed to do this after logging in and navigating to your settings tab in your selected repo. So once you've completed all of this, you can visit your newly published site. And if it isn't immediately loaded, wait a few to potentially 30 minutes and try refreshing the page. It usually only takes a few minutes, but occasionally takes a bit longer than that. I've included an example project up here that is a live demo specifically for this activity. So please feel free to copy, clone, or fork, or whatever, if you want to practice deploying on your own using an adapted version of it, or you can try deploying an entirely different project if you want to do something with, if you want to deploy something that you've already been working on, because the steps will pretty much be like the steps that are outlined here. So I'm going to give folks like 5 minutes to kind of go through these steps if they are so interested, and also check the chat to see if anyone's having issues or challenges. All right, so it seems like a few folks were able to get this started or going. And again, if you have any questions at all about this process or anything else from the previous sections or activities, please don't hesitate to post in the chat or on Slack in the Office Hours channel, or just to direct message me later after the workshop, or also after we conclude the formal presentation part. Okay, so finally, one last slide before we close out with a few additional resources for you to check out at your leisure. So these are a few links to resources that I think are interesting and relevant, but might not be exactly on this topic. So really just for further learning. So thank you all for sharing your evening with me. And I really enjoyed sharing the many joys of this library with you all. So again, please don't hesitate to come find me online or during office hours if you have any questions, want to chat about your hackathon projects, or just want to say hello. And I'm going to leave these links here for now. So like the other instructors, I'll also be monitoring the office hours Slack channel periodically to help. So I'm going to stick around until 8 p.m. To really give folks time to continue working on their hackathon projects or working on ML5 projects more generally, and to help anyone who has any questions or would like additional support in some way. So to everyone else, take care and good luck with your projects.